Um, and then the co-associativity means that if I do the same process first from delta with delta to u times u, but then I put the identity on the first and delta on the second, then the result will be the same. So it doesn't matter whether I will apply this way or this way, it will be the same. And also there is another rule which is fulfilled. Now I make a similar operation, however, so I start again with delta. So I go again to u times u, but then I have on the first factor I put the identity, and on the second factor I put the epsilon, which means that I'm going back to u. I'm going back to u, and then I require that this is the insertion of I1 means that this is the insertion of u times u in u time tensor f. So I went with delta on this, so I should have it on like this. And then on the first factor I remain what I remain, but with the epsilon on the second factor I'm killing it going to the number field, and so this is the same. Of course, this is not trivial condition, because it may be so that that it will be very complicated after delta. But the point is that doing this way, this is some kind of conditions which relate epsilon and delta, and that is the accompanying relation if after delta I'm using epsilon on the first factor and identity on the second factor. In that case, there will be the insertion into 2. Insertion into 2 is u times f tensor u. Okay, so this is, in fact, in a sense, of course, if you put basis, of course, you can clearly imagine that this that here we have the same elements as here, because here you only multiply everything by some number, but as elements of the algebra U, you have the same elements. So it is just this identification, the way to insert U in this tensor product. It should be consistent. So this is the definition of B algebra. It is B algebra because it has this additional, on top of being algebra, it has this additional homomorphisms. And now a B algebra, now we are going to Hopf algebras, as I mentioned above. A B algebra U is called a Hopf algebra. If there exists an algebra anti-homomorphism, I'll remind you what means anti-homomorphism, gamma, which is called antipod. So this is B anti-homomorphism means that, first of all, of course, it is from U to U. And anti-homomorphism means that if you have the product of two elements in the algebra, it will be the result will be the action in the opposite order. So you first take gamma of y and multiply with gamma of x in the opposite order. And you have a condition, as usual, related to the unit element, which is that gamma of 1 is equal to 1. Of course, this thing actually follows from the fact of follows from the fact of homomorphism, or maybe strictly speaking follows that gamma of 1 over u squared is equal to gamma of 1 over u. Because if you substitute this here, you obtain 1 times 1, it is 1, and you obtain the gamma of 1 to squared. So in a certain sense, you have this following from here, and then of course it's natural to suppose that also this will hold. In a sense, you have to cancel this, supposing that it's not 0. Of course, you suppose it's not 0. Okay, but that's how it is. And then there is an additional axiom which connects now the three operations together. This will act now from the Hopf algebra u to the u, and it will be the following sequence of operations. On the left side you start with delta, so you go from u to u, and then on the first factor you apply the identity, and on the second factor you apply the new operation, the antipode, and then at the end you just put the ordinary multiplication. In fact, here, so this means that for these purposes we introduce that m x y is equal to x point y. This is just a notation that m would relate the x and y, which from the tensor sides of the product, by the ordinary product in the algebra U. So you, at the end, you return here, and now on the right hand side, you start with epsilon. So you're going from u to the numbers, but then by the insertion, this is the same type of insertion. In the following sense, similar insertion. So it means that you have to say how numbers are inserted, and the way to say this is that u of some number c will be equal the number c multiplying the unit element. So c is some number from the number field. So in this way you again return to u. Of course, here you see that at the end of the day you'll obtain here either the unit element or 0, because of course it may happen that this c is 0. But in any case, you have this not too many choices. In a certain sense, in many respects, the antipode will play the role of inverse. However, we do not require. It may happen, but we do not require, in general, we do not require that gamma squared is equal to the identity. This may happen, but we do not require it.